Hello everyone, welcome back to our channel. I hope you are having an amazing day. In today's video, we are going to explore one of the most important block in Simulink, that is the scope block. Whether you are a beginner or already using MATLAB and Simulink, the scope is something you will be using almost every time in visualizing your signals. So let's dive in. In today's video, we'll be exploring few of the elements like what is scope block, Add, adding the scope block, inputs and access in the scope block, the scope parameters, all the settings required to change as per your desired signal visualization, how to add multiple signals in one scope block, and when you add those multiple signals, you need to edit its layout. It might be like left and right signal or up and down, and all the layouts we are going to explore. Then some of the measurement tools which MATLAB offers you all built in the scope block. We'll be exploring those all things. And at the end, we'll be doing saving the scope blocks as a JPEG or locking that data to the workspace wherein you can extract the values or the samples in the scope. So I have already opened the Simulink, and first of all, starting with the first thing, that is what is a scope block. The scope block is like an oscilloscope, a visualizer, to display and analyze the signals during a simulation. When you have made up a simulation, you have to analyze certain signals. To see the signals, the pattern of the waveforms and all, you need a graphical representation. That is where this scope blocks help us. Think of it as your window into what's happening inside your model. What can you see? The shape of the signal. You can check the system responses using scope, and also you can debug your models easily with the help of scope. Starting with the first thing, that is adding a scope into the Simulink model. Instead of going through the library browser and searching all the uh, you know Instead of going into the library browser and adding a scope, we'll use the shortcut, that is double tap on your screen, search as scope, it will just get added to your screen. Before taking an example, seeing lot of things, we'll just open the scope block. This is how a scope looks like, and we'll just open the scope block and see what all elements are present in this. Double tapping on the scope block, a graphical environment appears wherein when you double tap on the scope, this screen appears wherein you have x-axis, y-axis, a grid, okay, and few of the elements mentioned here like settings, display grids, run. You can run your simulation from the scope also, as well as going out in the simulation environment from there also. Some things like copy to clip and print to figure. Print to figure I'll be showing you all at the end. Then you have measurements in your toolkit. That is a lot of measurements are there like signal statics, peak finder. You can find the peak amplitude of your signal and many more. Okay. So to analyze this and all things, we need to just first let us print a signal on this. As shown in my previous video, we had used a sine signal, sine waveform. We'll use the same thing again so that it becomes easy for us to explore the block. I'll add a sine wave block. I'll connect it. Okay, so there are three options of connecting. One is click here, drag and drop. Okay, I mean drag and connect it to the required block, or else you can, click on this, then come back, click on the block where you have to connect. It will get connected on its own, something like this. Okay. Third thing would be when you just click and drag, a small icon pops up. You can just click on that, it gets connected on its own. So this is how you connect a scope. Okay. So I'm running my signal here for 10 seconds. If anybody is not familiar about this, all the toolkits present here on the top of my screen. You all can watch our previous video wherein I've explored all the elements in MATLAB as well as Simulink. Okay. So let me just change the amplitude of the sine wave to 2 and let frequency be 100. I'm just taking some random values for our verification, and I'll run the signal. I'll run the simulation. Okay, it's ready. When I double tap on the screen, you can see my sine wave is generated. It starts at 0 and till 10 seconds your simulation will run and you can see the waveform from 0 to 10. Okay, I'll do one thing. I'll show you all how to reframe the signal. Some advanced tools what MATLAB has given us. Uh, just see like when I zoom out or zoom in, my signal stays inappropriate, right? So in order to reframe it in a proper way, on the right hand top corner, you can see the third option wherein it zooms in a perfect manner that the entire graph fits to one screen. Okay, I'll just click on this third option and now you all can see like it starts from 0 till 10 seconds. Here my time axis on y-axis also is visible now. It starts from 0, sorry, x-axis. It starts from 0 and ends at 10 seconds. That is the simulation time which I was running it for. Now, certain questions and things which mainly academicians, researchers face is I cannot use a black background in my journal papers or in my thesis or something like if you're publishing something there. So in order to have a white background, uh, okay, and some of the elements which I wanted to discuss are like whenever you are just simulating a graph or a signal, if you're taking it or printing this as a figure or taking a snapshot of this, make sure like you are adding title to your graph. There is an x-axis, there is an y-axis. If you are using multiple signals, don't forget to add legend. Okay, that is very, very, very important. So first thing we'll be seeing like how to add, how to change the background of your scope. When I go to settings, I have an option called as style. Okay. In left hand top corner, I have option called settings. In that, I have an option called style. Just click on the style. A pop-up will appear here. Okay, in this pop-up you have all the options mentioned here. Okay, it generally by default takes you all to access style. Okay, so now access background, what color I would like to have, that is white. It changed everything to white. Okay, now my but I still want to have a grid at my background, and due to it is gray, my grid in the backside is not clearly visible. So I'll switch grid colors back to black. Okay, and let my scope background also be white. Okay, now you all can see like in a simple way I have changed my background of the scope from black to white. Okay, the next thing would be I cannot see the lines of my signal very properly, right? So for that I have here okay, so in line settings I have few of the options. First one will be like the type of line you want. It may be a straight line, small dots, larger dots, very larger dots. Just click on that. You can see all in the back side. You can see all my graph has changed it from a line to dotted lines. Okay. For for our understanding, I'll keep it to line. Okay. Then here you can change the thickness of the signal of the line for our more visibility. If I make it 2, it becomes more thicker. Okay, marker also you can use like a dot marker, a plus marker. At every point of time a sample is collected, at that particular point it adds a marker. Okay, so I keep it as none right now. Color, we can choose whatever color we want. It may be red, purple, yellow. Okay, I'll keep red for more visibility. Okay, this is all you can change for access as well as line settings in the scope. Okay, now in when I go to general settings, I have something called as open at simulation start. What does this happen? Okay, I will for our understanding I'll just click it. Okay, no need to apply or save changes here. because this new MATLAB version has this feature of auto saving everything. Okay, so I'll just click it, it gets auto save. I'll just cancel the settings. I'll close the scope. Okay, I have selected open scope on simulation. Now just see what happens. As soon as I hit the run button, my scope opens immediately. So whenever my simulation runs, my scope pops up on its own. No need to go double tap and open on the scope icon. Okay. So next we have number of input ports. If you have more than one signal, you can add this like 2, 3, 4, 5, 6, depending on number of signals you want to see and analyze in one particular scope. Time being, we'll leave it as I'm going to take up this after some time. Display grid helps us in order to have rows and columns for if you are having multiple signals. Okay. So what type of input processing you want to have? It may be elements as channels or columns as channels. Why they have given columns as channels and element as channels is some people want to have frame based analysis and some people want to have sample based analysis. Depending on what type of analysis you want to have or what type of scenery you want to see, depending on that you have to select the option. By default, it comes as elements as channel, that is sample based. Okay. So once general settings are over, I'll just close this option. Okay. Second will be time. What is this time? Sample time by default remains to -1. You can change it as per the number of samples you want to collect. Okay. If I click 10 here, it means it is going to collect only 10 samples per second. Okay, by default -1 it shows, it means it is collecting on its own the maximum samples it can collect to give you a proper output. Okay, time span, you have option here. uh, by default your scope will be running from 0 to 10 seconds, but if you are going for select that is simulation times. I have set a 0 to 10 seconds. Your scope will be showing 0 to 10 seconds. But if you want to change it, you can go here instead of auto, you can switch to user defined or no, like just okay, I'm sorry, that is user defined, that would be 10 seconds. Or now if I add only 1 second and click OK, now you can see my scope displays me the signal only from 0 to 1 second, no matter even if my simulation is running for 10 seconds. Okay, let me just click it on auto. Auto takes the simulation time itself. Okay, so some things like wrap and all. There are a lot of other options. Time into units, seconds, and metric based. Time display offset you can choose. Now this option to add x-axis, you have to go in axis style and in the display option, and then you have to do for mentioning. By default the y-axis, sorry, x-axis would be time. So that is where you will use this. When you click on OK and show time access label, then I click on this, you can see there is a time mentioned below in my x-axis now. Okay, so these are very important. Time should be added in the x-axis so that it helps the people to understand what is my x-axis and what would be my y-axis. So once my time is done, access scaling, in terms of access scaling, there are two things: manual, auto, and the things. And depending on the values you want to only see on the screen, you can choose your kind of access scaling. Okay, now coming to the next part, logging. Data logging. We'll take up this at the end, so I'll just leave it for right now. Access styles, we saw the background of the scope, how to edit the color in this. Line style, changing the color and size and the type of line you want, along with the marker points also if you want. Now comes y-axis. This is the important part. So my y-axis was representing as amplitude. Just type here amplitude and just click outside the screen. You can see my y-axis is labeled as an amplitude now. Okay, there are limits he mentioned here, starts from -2.4 and ends at 2.19. So that is where you can see from 0. My graph starts as 0, but it actually shows me displays me the value of the lower limit and upper limit of the signal which the peak of lower and upper limit it has reached, that is -2 to +2 only. Okay, so and you can change it from here also. If you change, your scope will get crop, and there may be chances of missing some of the peak signals also. Next part will be display. Display here it will title your graph. Okay, so that is, I'll do it as sine wave. Click OK and just take it away. You can see my graph has been titled now. Okay, so once you are doing this, there are plot as magnitude, phase, and show legend. Show legend just gives a small option here on the left hand corner, top left. You can see in older MATLAB it comes inside the graph on the right hand side here, where you can see my cursor right there. It will show you individual color and what that color it defines as. Okay, so once I click cancel, now you can see like this graph. If I take a snapshot, or if I print to figure, I can upload it in papers, or I can use it in some places where I have to do some publications. So this becomes a valid kind of graph. So next we'll be taking up to add multiple signals in one scope. Okay, let me quickly minimize this, and when I open the sine wave, let me switch the frequency to 10 so that more number of less cycles I can see in my scope. Okay, there are so now there are two options of adding the input to the scope. Okay, for example, if I want to add two scopes, okay, two signals, the first method would be, okay, now one more shortcut element I'm going to tell you all. In order to copy and paste this element, you have two options, that is using your keyboard shortcut, that is Control C, Control V, Control C, and Control V. It got copy pasted, right? So, or there is another option, right click. I'm telling it again clearly. Right click on your screen on the block, and without leaving the click, just drag it and drop it down. It gets copied. Okay. This is another shortcut method of uh, copy pasting the blocks in Simulink. Now, in order to reframe my Simulink, as I mentioned in my previous video, you are going to use, there are two options. Either you can click on this option here, left hand side, fit to wave, or you can use spacebar. Just by clicking spacebar, it will reframe everything. Okay. Now, coming back to the signals, now two scopes are there. Now I have two scopes, one with amplitude 3, one with amplitude, the previous one which I had saved as amplitude 2, let it be as amplitude 2. Okay. Now in order to merge these signals in one scope, okay, there are two methods. Click on the signal output of from the sine wave, drag, just push it inside the scope, okay, and leave it. Now when I run my simulation, okay, and I run my simulation, you can see my both the sine waves are printed, one with amplitude of 2, one with amplitude of 3. Now I will reframe it using this again. Now both my signals are visible in one graph. Okay, one is blue, one is red, and also legend, as I had selected, it automatically shows it as sine wave and sine wave 1. Sine wave 1 is the second one. Okay, now you have here option called as display grid, right, on the left hand side. When you click on that, you will get different display grid option. Okay, so if I choose one column, sorry, row 1, 2 columns. Now my signal modifies is like that. It splits the number of input signals given. Left hand side would be sine wave, right hand side will be sine wave 1. Okay, if people are preferring to have up and down, you can select two rows in one column like this, up and down. Just click it and it splits the signal into two. And now you can have entire snapshot of entire graph, and you can use it wherever you all want. Okay, so now I have shown how we all have to take the display grids. Display grids will be of more number of types. Okay, I'll do one thing. I will show you that also. I'll just zoom out and I will copy paste this into multiple. Okay, and one scope at the end of the corner. I will drag it so that I can add it 3, 4, 4, 5, 6, 7, 8. Okay, I've added 8 signals and I'll run it. When you have not splitted your graph very properly and my other amplitude signals were like 3, only my first one was 2. I've copy pasted the blocks, right? So now what will happen is you can see like all the signals are printed in 1 in the second graph, like sine wave 1, 2, 3, 4, 5, 6, and 7, and the first one was in here. Now, total number of signals are 8. So either you can have them in one go like this, 1, 2, 3, 4, 5 can be fitted in one line, but as I have 8, I take it as 1, 2, 3, and 4 like this. And I click OK, you can see all my 8 signals are printed here. Now, all the colors are looking same, right? No, so again, I'll go back to display settings in my line style. Yes. Okay. So now when multiple signals are being given as input, you have here active display 1 to 8. Okay. Now first display was my red, second was yellow, third I will change the color to something like green, fourth one I will go for blue, fifth one I will go for pink, sixth one I will be going for some orange, seventh one, okay, running out of colors, something like black. Then eighth would be, okay, I'll use this color. And if you are running out of colors, there are palette option here. There is color palette where you can manually add the type of color you want to have. Okay, I'll use this color. This is, sorry. Okay, now this color, whichever I have chosen here, gets added to the graph. Now, this is how you edit multiple signals in one scope. Okay. So now one more thing, as I had mentioned earlier, there are two methods, right, for giving input. Okay, as I mentioned earlier, there are two methods of giving input. One was dragging and dropping it inside, right? The second method would be go to scope, go to settings, in general properties, sorry, okay, in settings, when you go, you can see here number of input ports. Okay, I will make it as 2. Okay, just click outside somewhere here and close the settings, and when I close the graph you can see my scope has now 2 inputs, so you can just drag and drop signal here also. Okay, when I run the signal, both the uh, signals display here. Okay, again you can change as per your requirements. Now there are some additional features in scope. Okay, that is measurement block. Now what I can do in measurement block is I can go and have peak finder, label peaks, number of peak finders and all. So I've selected the above signal. Okay, you can select whatever signal you want. Here you have channel selector, wherein first one is sine wave, second one would be sine wave 1. When I click sine wave 1, it automatically takes to the second one. Okay. Now, when I go for statistical analysis, what all elements you want? Peak to peak, mean, RMS values. For example, if I select on RMS values, okay, and then when I click on this, below you can see like it clearly mentions me time and the RMS value 2.10 is my RMS value for my, that is root mean square value for my entire signal. Okay, and if you want something else like peak to peak, it will give you peak to peak value also. If you want to find only the mean, it will give you mean, median. Okay, this reduces your time to sit and do calculations and all. When I add peak finder, it will give me peak 1, peak 2, peak 3. There are different uh, icons mentioned here, you can see. Okay, if I want to change it also, you can change, but these are the peak values. The maximum peak the amplitude has reached, only those three signals it has taken, and it has printed it for me. Also, it has mentioned me at what time period of the x-axis it has mentioned. Okay, so there are different types of signals like continuous and discrete, and this would be very helpful for us in that, wherein continuous signals it becomes very hard to find the time. Discrete signal they can be easily analyzed using the sample. So these things help us there. So this was all about scope and its settings. I will delete this channel quickly. So okay. Okay, so now let us see how to log your data to workspace. Okay, now when I open the scope, go back to settings. In settings, you have something called as logging here, right? When you click on that, there are a lot of options like limit data points and all. Okay, now the last third option, log data to workspace. Okay, when I click on that, it will show me what I want to do. That is scope data to label. So now the best format to log would be in terms of structure and time. Okay. But if you want, you can also switch to data set alone or array or only the structure also. Okay. I will switch to structure with time. Once you select that, make sure you run your simulation again. Uh, a pro tip point here where if you are running heavy simulations, make sure you are logging your data set. You are changing your settings to data logging before running the simulation, because your data logging happens after your simulation compilation is completed. Okay, so I have to run it again in order to log the data. Now, once I click that, you can see here on the workspace on the right hand side, my log data has come here. I'll just go inside that, taking time. So now I have scope data, the scope data was the one which I've logged. Okay, just double tap on that. You can see different elements here. One is signal, one is time. When I go in time, these are the time periods at which the sample was recorded. Okay, then comes your signal. Signal has different dimensions, labels, and all. We'll go only to values, and these are all the values of the signal from a sine wave, that is positive to negative, back to positive, back to negative. It has plotted all the data. So total number of samples collected were only 52 for a 10 seconds of simulation. Okay. And if you want, you can go back. I'll be okay. Now, if you want to extract these values in an Excel sheet, you can. There are two options, either copy pasting from here and pasting it in Excel along with the time also from the previous time which I had showed, or else there is another option using a extract from the workspace to an Excel that we'll be seeing in our upcoming videos. So now coming back to the next version, that is saving it as a JPEG or PNG. Okay, so this is my scope. I'll reframe it. If you want to zoom anything, you have zoom option here. It might be only zoom, or you can directly use your cursor to zoom in. As you zoom in, you can see your time period also varying, or you have the y-axis zoom, sorry, x-axis zoom. Either you can zoom in only x-axis or you can zoom in only y-axis, something like this. If I use this zoom, that zooms my y-axis. Okay, I will back to normal zoom. Okay, this selector, there are three options, one for y-axis up and down, one for x-axis that is left and right, and one is general wherein you can move as per your requirement. Now, to there are two methods of extracting the graph. That is, one will be using your print screen option or snippet tool from your keyboard settings. Or okay, if you want to save your graph as a picture or PDF, if you want to save it as a PDF, you can use the print figure option. And if you want to uh, print it as a picture or figure, you can use print to figure. When you click on print to figure, you can see here. it appears like this. Okay, now you can have your figure labels and all, everything you can change here. Okay, then you have a save as option. Okay, you can just click and save it as a figure, a PNG, or you can export it as a PNG or PDF. Let me export it as PNG. Select desktop and close it. Okay, now it has printed. Now double tap it, you can see it has printed it as a PNG. Okay, so make sure, like, if you have clicked on any point and all, it will take a snapshot as it is. So uh, any point of here, if I want to see my signal of x-axis y-axis, just click on that point, it will be showing x-axis y-axis, and at that time if you click as save as, it will print as it is. So these are few of the settings and all uh, present in scope to do different analysis, peak, RMS and everything. So let me do a small experiment here. Let me add a transfer function block. I'll use the default values. Okay, I'll not change anything. Okay, and I'll take the input 1 from here. Okay, now if you want to add a line from here to the scope, right click on the line, drag such that an additional arrow comes up, which will make an additional connection here. Okay, now I'll open my scope, I will run my signal, and after my transfer function, you can see the second one, transfer function value. I'll make it as a grid. You can see first one is my normal sine wave, second one will be my transfer function block. Okay, now if I print to figure, go to figure option. Okay, there are a lot of other options where you want to title, subtitle, Y label, X label. Those all things also you can change from here also, not necessarily in the scope. But make sure before exporting it, you change it. Okay, just click as save as, go back to desktop and untitled, save it. Okay, so you can title your graph and save as the way you want. I'll minimize this and it has saved here. Okay, so this has exported as a graph. This still opens only in a MATLAB function, right? So instead of doing that, I'll go back here, I'll export it as a PNG. Click back desktop again, save, yes. Okay, so now when I open this, you can see it has printed it as a PNG. So this was all about the block scope and all of its settings. Okay, I've covered the major elements which we can use to uh, analyze the signals as per our requirements. Okay, and some of the best practices, let me discuss here very quickly that, and some of the pro tips from my end. Make sure always label your signals so that you don't get confused. Don't overlay a single scope with too many signals. Use multiple scopes if required. Okay, it's not necessary to have all the signals in one scope. If required, you can have multiple scopes on the screen also. Now, for heavy simulations, scope can slow things down. Okay, make sure when you're running very heavy simulations, your scope will slow down your entire simulation. So, log data to workspace for post processing instead. Okay, and if you need beautiful plots for reports or papers, log the data and use MATLAB plotting function. The plot option which I had shown in my previous video, you can use that also. Okay, now I hope this video has given you all a lot of knowledge regarding scope and its settings and everything. I hope I was very clearly conveying all the things to you all. Make sure to subscribe our channel, hit the bell icon so that you'll never miss an update. Make sure you'll share our videos to all the people out there who are new to MATLAB, who are beginners and who are using MATLAB for in their research or academic projects or industry, so that it will help them in order to get some beautiful outputs and to make their projects work in a really better way. Okay, and here, Pratik Deshpande signing off with this video. We'll be coming up with beautiful and amazing videos very soon. Thank you.